Hi, KC1SA here, and today I'm going to talk a little bit about POTA and the trials and tribulations of having a nice, quiet, from an EMI standpoint, laptop environment where you can use your radio and not be disturbed by a lot of EMI coming from chargers. So my radio that I use for all my activations is an older Kenwood TS2000 is my backup radio. I have a ICOM IC7610 as my base station at home, and I use the TS2000 when I'm out activating. For logging, I use an older Lenovo T420 laptop. It's pretty old, about 10 years old, and the battery is that old as well. And it lasts about an hour on a full charge. And so I'm constantly plugging it into this DC to AC inverter that I got from Harbor Freight, and it's very noisy, and it basically drowns out anything on the radio from an EMI standpoint, so you can't listen to anything while it's being charged. This is what the charger looks like, and contrary to what it looks like, it's got 3 pins on the charger. It's got an internal and an outer ring. An internal ring and an outer ring, that's plus and minus voltage, and the center pin, which is not connected to anything. And so that was very noisy, so I decided to purchase an aftermarket DC to DC inverter for the T420. So it takes 12 volts from your cigarette lighter and turns it into 20 volts that the laptop needs. But this proved to be very noisy as well, just as noisy as using my Harbor Freight inverter, DC to AC inverter. So I needed to look for another solution. Prior to retirement, I had about a 40-year career in electronics, and I supported, from a field application standpoint, linear technology, analog devices, products for many years. And in particular, one part that came to mind was the LT8337 silent switcher. The silent switcher is technology that analog devices, linear tech came up with that basically, through unique packaging and circuit layout on the IC, magnetics cancel out any EMI that is generated. So they're quite unique in their product. These are the features and benefits of the silent switcher devices. Ultra low EMI emissions. They have integrated FETs capable of up to 5 amps switching. Very low power and high efficiency. So they're great products. Very inexpensive. This particular part in 100-piece quantity is about $2.77, so under $3. By the time you add inductors and PC board, you can build this circuit up for less than $20. So this is the evaluation board from Linear Technology Analog Devices, the LT8337. It is all surface mount. You can see it's a very small PC board, about 2 inches by 2 inches. This is another view of it. And you'll see in the following a schematic, I tried to figure out how am I going to change the resistor, the feedback resistor, to set the voltage correctly. It's going to be a challenge since I have no surface mount equipment. So this is the LT Spice model for the evaluation board, and in particular R2 has to be changed. Right now it's being set for 12 volt output, 5 volt input, and I'm going to be running it at about 13.5 volts with a 20 volt output. So that 90K resistor has to be changed to something different. So the value that I came up with using the formula listed above is 52.6K. And so how do I get to 52.6K with a 90.9K resistor on the PC board? Basically, I have to parallel a 124K resistor with the already existing 91K resistor on the PC board. So I basically there's a optional capacitor that isn't stuffed on the board, and that's where I'm going to place it. I then ran through LT Spice simulation to ensure that the voltage would be achieved, and the simulation looked pretty good. I am skeptical about getting 4.5 amps out of it, but we'll see how it works out when I actually make the modifications to the board. And here's the modification done to the board. It's not pretty, but again, I don't have any surface mount equipment. After it was tacked in place, I then put some hot glue on it so it wouldn't come undone, and it seems to be pretty sturdy. And then I proceeded to basically print up a case for it with my 3D printer. This is it set up and actually running the laptop off my lithium iron phosphate battery. And this is the case that I printed up, 12 volts in, using Anderson power poles on the input side, and on the output side the same thing. And that's the laptop charge plug plugged into it, and seems to work pretty good. Now we're going to show you a couple of videos. Videos are the best way to get the noise level, as you can see. The first video is with the commercial DC to DC plug in the cigarette lighter inverter. Currently right now it's being plugged in and powering the laptop. I just unplugged it and you can see the S level meter went way down. So the commercial inverter is quite noisy. Now we're going to show the LT8337 inverter that I made, and it's going to start. This is powering the laptop. This is not powering the laptop. Powering the laptop. Not powering it. There's really no difference in noise, so it seems to work pretty good. Next proof will be when I'm out in the field and see how it works out. Hopefully this is informative to folks, and maybe it'll challenge you to build your own DC to DC step-up power inverter.